Alrighty then, welcome to the Daily Space Weather Show. I'm your host Dan, aka Smash-A-Mash, coming at you from the Smash News Network, least busted name in news. That's the past couple of hours. We had an X-class flare and one nearly X-class flare and a minor little baby CME impact that you don't have to worry about at all. We do have some massive solar plasma filaments, though. That's something to check out. In the southwestern limb there, trailing that active region that's produced the X-class flare. Massive plasma filament there, and some also massive plasma filaments closer to the equatorial portion of the eastern quadrant of the disk. And we'll show those more in depth a little bit later after we show the recent coronal mass ejections, like the one that blasted off today, associated with that X-class flare. So yeah, we'll be covering that. Also, we're going to do a cosmic ray report today because we haven't done a cosmic ray report for a long time. So cosmic ray flux is still at a 20-year low. However, we've had an uptick in cosmic ray flux over the past 30 days at most monitors. Keep in mind, we just had a 4-bush minimum just about 30 days ago. So you're going to have a very low levels there going back 30 days. So that's the past 30 days at Oulu, Finland. Here's DOMB Antarctica. Few days of missing data there at the end for the Antarctican monitors. We'll head down south to Mexico City. As you can see, also an uptick for the past 30 days. Now the Greek monitor, the Athens, Greece, it's got a bunch of missing data there as well. It is flat over the past 20 days. Last but not least, Barentsburg and Apatity. I'm sure they'll be up over the past 30 days as well. So again, a 4-bush, those are both 4-bush minima back there. That is what happens when significant geomagnetic storms strike Earth. That's the data from Cygnus X3. We won't worry about that. And let's take a look at some more imagery here of the closest star. There is that's a composite set of wavelengths. That's 304 plus 193 angstroms. And yeah, X-class flare happened today. We'll show you more footage of that a little bit later. First, a bunch of additional space weather data. 10.7 centimeter radio flux is at, I don't know what it's at. It's at 178 solar flux units. And there it is over the past year, depicted by the black line. 178 here, so... And if you saw last night's daily space weather video, you may have heard me say that you can expect levels of solar activity similar to what we have now for approximately 8 months. So that's good news for all you space weather enthusiasts out there. And as you can see here, the space weather enthusiast dashboard forecasting as high as a KP6, very similar to the forecast that we came out with last night. They did underestimate the speed, or they overestimated the speed a little bit, so it arrived about 5 hours later than expected. So both ESA and NOAA agreed. They were both off by about 5 hours. Not too bad. And the incoming solar wind speed right now is just under 500 kilometers per second. We'll show you the details on that here in a minute. There are those forecasts. That's NOAA. There's ESA as well. And if you're wondering if today's CMEs are headed toward Earth, again, we will cover that a little bit later in the video. So here's what the current situation looks like on our geospace magnetosphere movie model. Now that model is based on a whole bunch of different sets of data, everything from the magnetic field, solar wind density, solar wind velocity, the magnetic field intensity, the magnetic field orientation in terms of the vertical component, Earth's electron flux, all sorts of things are in those models. That's the past 4 hours of what Earth's magnetic moment from space is likely to look like. Now, you can use the ground magnetic perturbations map to take a guess where you might see the aurora. So if you'll go out and check to see the aurora tonight, you might be able to see some at mid-latitudes. Although so far the CME impact has been looking weak, so don't expect too much excitement unless you're in an area that is typically going to be likely to see aurora anyway. KP index there, barely getting into geomagnetic unrest at KP 4.33. Geomagnetic unrest, not even a full-fledged geomagnetic storm, really. So there's the ACE. CME impact occurred right around 16:30 Universal Time. 16:30 Universal Time today on June 10th. So it was pretty weak. If you follow me on Twitter, you might have seen a pretty rapid update for that. There was just some good timing there. We did see a little bit of a field variation happening there. It looks like it's already subsiding. Now keep in mind that CME wasn't expected to completely strike Earth anyway. It was slightly off to the south and west. But not a strong impact measured by the Discover either. You can see it did arrive there around the same time. Current conditions at Discover are about 9 1/3 protons per cubic centimeter, 475 kilometers per second for the solar wind velocity. Magnetometers here did show some spikes, of course, around 1600 there. So perhaps some pre-impact magnetic field action happening there on Earth's side of things. The GOES 16 is located at about 23,500 miles of altitude. It's way up there in Earth's outer reaches of its outer Van Allen belt. The outer portion of the outer Van Allen belt. Next, the heliosphere magnetism. And Earth is still in a South Pole current sheet. Come tomorrow, Earth will still be in a South Pole current sheet, most likely. I should say a South Pole-oriented magnetic sector. The current sheet is the area between the sectors, and we ain't got no sector boundary crossing. Well, there might be a sector boundary crossing by tomorrow, but it'll be close. It'll be sometime around when we produce tomorrow's daily space weather video, I suspect. Here's our line-of-sight field plot depicting the solar B field, photosphere magnetism, and polar fields all at once. And here's our coronal hole map. Not too exciting with coronal holes right now. We do have North and South Pole oriented ones there as the solar polar field reversal process continues. Let's take a look at coronal holes from the perspective of the SDO. Sup with that?
Well, you know...
Before we do that, a little teaser. We've released a new Ask a Particle Physicist segment, and there's part of it, so make sure you check our playlists. Also, an interesting paper came out suggesting that we've got the dawn side counterpart of Steve. So there's a great paper that you can read. We shared the paper directly on the Twitter feed. It's x.com/smashomash. And it's kind of like a piece to the puzzle. I mean, this is sort of the only rational explanation. It uses swarm data, and it's pretty good. It's pretty good. And yeah, it's basically Steve, but at the dawn side instead of at the dusk side. A little bit different the way it operates in terms of the physics and stuff. So have a read if you like. Again, it is linked on the Twitter page, so feel free to follow us over there. So here is the 211 angstroms wavelength, and the most well-defined coronal holes are near the poles, and they are actually north is the southern portion down here, and then up there those are South Pole oriented coronal holes. So, but no real major action expected to be coming from those, which brings us to sunspots. So sunspot number here continues to dip. It looks like it'll be stable into tomorrow. We've got about 120 sunspots at the moment, maybe 121, something like that. Sunspot 3709 is the most promising sunspot on the Earth-facing portion of the disk to see a large flare. 3709 is not particularly exciting, however, so don't expect a whole lot of fireworks from it. Here is the SDO magnetogram for the past 24 hours. Again, most of these groups stable for that period. We'll also show SDO continuum. And the most likely place for large flares is around the southwestern limb, the southwestern portion of these sunspot groups right here. But besides that, it's not looking too bright for as far as major flares. We could still see some action down there in the southwestern limb, but yeah, things are pretty chill as far as flaring goes. Don't expect a lot of big fireworks in the coming day or two. So as far as the flare probability monitor, let's see what it has to say. It's not going to be too high, I don't think. And indeed, you can see Sunspot 3709 is on the list there. That is the most likely place. The monitor agrees. The monitor agrees. So, I mean, and a lot of our viewers are, I'm sure, able to pick out these same features. This is not rocket science. It's a lot more complicated than rocket science. But in any case, here you can see the proton flux subsiding as forecasted yesterday. No new events have shown up. So despite a large flare, no new proton events. Also, you'll see the polar radial blackouts here subsiding later in the day today, in the past few hours. And by the time morning rolls around, there should be pretty much no polar radial blackouts. Here's that flare we talked about. It was an X1.5. And let's move to flares from SDO. That's pretty good. Yeah, not half bad. Not half bad. What do you say? If you enjoy the content, don't forget to press the like button. If you're new to the channel, don't forget to press subscribe. If you've never checked out the playlists, check them out. And how about a little closer view here? So even though the second event looks brighter, it's actually a smaller flare. So that last event is actually only an M9.3 or something like that. But keep in mind, folks, it gets a little bit sketchy when you get close to the base layers, the base levels of each order of magnitude transition, because it's 10 times, but it's almost, anyway, it's darn near 2 X-class flares there right at the end, both coming today. There's an even closer view for you. And that's not half bad. That is our T-mass, the most active sunspot, not even in view anymore. And we've covered that phenomenon enough times on the channel. Sunspots closer to the limb have like about a 5% higher likelihood of producing a large solar flare, statistically speaking, at least according to Mr. Bagashov's statistical analysis. I believe it was about 13 years of X-flares. Or it might have been M5 through M5 and up flares, I think it was. He might have done 2. I can't remember. There's 304 plus 193 angstroms for your viewing pleasure. Number 1, if that makes you want to take a number 2 in your pants, it's time for a visit to the brig. Note the massive filament rotating toward the Earth scale. Massive plasma filament there. And like I said, there are several that are a little bit more on the Earth-facing portion of the solar disk. So we'll get to that here in a minute. First, a solar system forecast. This is where planets currently lie. That's where things will lie in 1 week. And people are going to say there's a spooky, spooky conjunction or something, and that's going to mean a thing to someone because reasons. So here is that's what's going on overhead where we're located. Jupiter just setting, trailed by Mercury, the Sun, and then Venus. It will leave a high crescent moon in the sky shortly after dawn. Our astronomy photo of the day is the Lion Nebula. The Lion Nebula. And if you can't make it out, when I zoom out, it'll probably be a little more clear to you. I think it's a pretty good name for this one. Let us know what you think in the comments. There it is. the Lion Nebula. And you can check it out if you like at apod.nasa.gov. There's the full view by Imran Badr. That image is gooder than a lot of images of the Lion Nebula. I suspect that's multiple wavelengths there. I suspect it's probably oxygen, hydrogen, maybe even sulfur or something like that. Let's see if it says on the... What do you got? It's not telling us what the metals are in there, but let's move on because these videos should not be too lengthy. All right, so here's coronal mass ejections, and we do have the data from George Mason University back. We also have some fast-moving stuff happening there on the coronagraph. What's up with that? Is that a small comet? Not exactly sure. Let us know what you think in the comments. And so here is the CME from today. Definitely not earthly directed. It's from behind the western limb. And our data should corroborate that. As far as stereo A goes, it's got outdated data. Very, very ancient, outdated data. All right, so here are our custom coronagraphs. One of the most important features of the Daily Space Weather content. We put these together daily so you can see what's going on, what's blasting off. Again, lots of filaments on the Earth-facing portion of the solar disk. And remember, folks, you don't need to see a solar flare. You don't even need to see a sunspot to see a major coronal mass ejection. So that's what's going on. That is no new ejecta headed in Earth's directa. And I don't know why I failed to include the LASCO C2 on there. That is an unrecoverable error attributable to me, as I admit it when I screw up. So there is our, let's cut back to filaments view. We're going to bring you back to filaments here to close out the video, but we'll cut back to filaments there from Big Bear Observatory. And you'll notice that there are several filaments on the eastern hemisphere of the solar disk. So again, no solar flares or sunspots are required for a coronal mass ejection. They happen all the time without those other features. Don't get a solar flare and a coronal mass ejection confused. They are separate and very different phenomena. Solar flares are photons. Coronal mass ejections are protons. It's important to make this distinction because, again, they are separate phenomena. So here's our grayscale view, and we do have a prominence there. In other words, that southeastern filament, which would be your screen lower left, is a little bit out of view yet. It stretches all the way around that southeastern limb. Anyway, before we get to bonus features, here are the past couple of hours from the GOES 16 SUVI. And it looks like some more flaring is still occurring down there in the southwest. So we could still see more, significant action from that. The likelihood of it producing a proton event at this point is kind of low. But keep in mind, filaments can blast off at any moment, so we could see CMEs. High likelihood of CMEs, including the Earth-directed variety. So here come bonus features. First, charging hazards. We do have some charging hazards there of the surface variety. That is when low-energy electrons build up on the outside of spacecraft, and it usually only causes minor communications breakdowns. The GOES electron flux here kind of low, something that you would expect to erroneously see during a geomagnetic storm or unrest condition, which we do have geomagnetic unrest right now. So there's the forecast model, and we did have a missing observation there yesterday, and so no forecast today. I suspect they will have over-forecasted the electron flux for tomorrow. If you disagree, agree, or are indifferent, make sure you leave us a comment and tell us all about it. Next, we'll show the layer where it's measured. At about 300 kilometers, you have the F layer, which we show that so people understand the complexity of Earth's atmosphere. A simplified shell draw. Anyway, here is our ionosonde, courtesy of Australian Government Bureau of Meteorology. And things are chill in the ionosphere. Everything looking quite normal. Or I should say, normally. Be normal when you look at things that look normally. So here's the anomaly gram, anomaly in megahertz from a 30-day median. And let us know in the comments if you think the South Atlantic anomaly has moved. It looks like it is on the South American Atlantic coast now, instead of nearly in the center of the continent. So maybe that's something to be spooked of if you're spooked of space weather. The South Atlantic anomaly has moved, folks, which means it's bunker time. Bunker time. Everybody get in your bunkers. So here's our global ionosphere nowcast. The left panes will show you where electron flux is going on and anomalously going on. That'll tell you where GPS errors are most likely. On the right, maximum usable radio frequency. And, yeah, some likely chances for Steve and its dawn side partner. So, yeah, it's might be a night to go check out for the aurora. Of course, especially around dusk and dawn. Anyway, that's what's going on in the ionosphere. A couple more images of the closest star here. There is the latest continuum and magnetogram. I'll take a look at this sunspot here. Not that magnetically complex, not that likely to produce large solar flares. Anyway, that's what's going on. We'll close out with this lovely image. Ah, yes. The 304 plus 193 angstroms is very good at showing plasma filaments. So that'll be the story. That's really the story of the day, plasma filaments. In any case, thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-a-Mash, headed back to the bunker. And while I'm down there, may that solar wind be at your back.